Good evening to all. Hello, dear students. Today, on continuation of our electrical estimation and installation subject, we are going to learn an important and easy and general topic today, that is the estimation of overhead lines. So before that, let us introduce myself. My name is Dr. C.H. Yadaya, Senior Lecturer in Electrical and Electronics Engineering, Government Polytechnic, Islamabad. Today's topic is distribution lines of 11 kV and 400 volts overhead line introduction, basic things. Now, let us see what are the basics regarding transmission and distribution of our power system. If you know the basic things, we can easily estimate the distribution lines, its materials, its costing, as well as the transmission lines and its costing also. Now let us see what are the different parts involved in our transmission system as well as in distribution systems. Today's topic is just like the basics. On completion of this topic, you would be able to know factors affecting on selection of power lines, classification of power lines, main components of overhead lines. These are the few topics today we are going to learn. So the problem regarding to overhead lines estimation we will do tomorrow. Today, so only we are focusing on what are the components present in power system and distribution systems, what are the its characteristics, how they can used in our real world, and so what is the purpose. Let us see one by one and clearly. After knowing basic things, we can easily make as a schedule, that is the estimation of overhead transmission lines for LT lines and HT lines. Now, what are the factors affecting on selection of power lines? As we know that the power lines, so in our day-to-day life, so power is a very vital, plays a vital role. Now, if you are seeing, now as we know that the economic development of any country mainly depends on the effective utilization of available resources like our electricity. If you are going to the before independence, the what is the our electrical energy installed in our India. For example, so electricity, now the electricity covered nearly the 99.7% of villages in India as on today, but in 1947 before only few megawatts only. If for example in 1915 our total installed capacity of electrical energy is only 105 megawatts. That means very low value. At the time of the independence, that is 1947, it is drastically changes from 105 megawatts to 1900 megawatts power generation. That means it's a drastic improvement. So as on today, for example, here if you are seeing the 30 January 2020, our installed capacity is equal to the 321.054 gigawatts of energy. That much of the energy we are generating today, gigawatts, and not in megawatts. In gigawatts we are generating the our electrical energy in our India. So in that, how we are going to generating? So we have the conventional energy sources and non-conventional energy sources. The conventional energy sources by using the fossil fuels. That means nearly 79.8% of fossil fuels are utilizing for generation of our electrical energy. For example, coal, peat, diesels, this much. And coming to the non-conventional energy sources, solar energy, wind energy, so this type of the energy sources, so we are going to generate this energy also 17.3%. So these are the latest technology we are using, the conventional as well as the non-conventional energy sources. We are generating this much of the 321.054 gigawatts of electrical energy we are generating by using all the hydropower station, nuclear power station, and thermal power station, and small mini hydropower plants or diesel plants, tidal plants, wind plants, all things. So we are generating this much of the energy, and we are covering nearly 99% of the villages as electrified. The REC scheme we are implemented. Now, due to this one, what is happening? Our transmission capacity also increases. So now, latest our transmission maximum voltage in our India transmission is 765 kilometers. That is covered in India nearly 3120 the circuit kilometers. At the same time, previously, so we have the 400 kV is the highest transmission voltage, but it is now voltage increased from 400 kV to 765 kV. So this only transmission line nearly 3120 circuit CKM capacity. At the same time, 400 kV also it is covering nearly 7200 CKM. So these are the large transmission lines. The totally network is covering our India. Now let us see what is the need to learn here. So that means here first we have seen that factors affecting on selection of power lines. The power lines, that is the transmission lines or distribution lines. So what are the, before going to erect selection of these transmission lines, what are the factors we have to consider? So here we have to consider mainly these transmission lines or distribution lines. We have to consider the main factors as the length of the line first of all. So whether what is the length of the line we are going to install. So based on the lines we are going to select the line design. Next, what is its structure also. So we have to structure also we are keep in our mind before selection of design of the line. Now at the same time, after structure with the transmission lines structure, then after that we are going to choose the which type of the insulation is required for supporting things. After that, what type of the switchgear and protective equipment to be used, that is also play the major role. After that, next we have to think that, so what are the chances to fault may occur on the line during that places. So that means also chances of faults also we have to consider before going to select the line design. Next, the how much voltage may be dropped due to the long distance by using this much. What is the regulation? So this is also you have to keep in your mind. And lastly, that is the weather condition also. That means if you are erecting the transmission line, what is the wind force on transmission lines as well as our structures. Next, not only the wind force as well as some places we are going to see some deposition of ice. If ice deposit on transmission lines, automatically the sag also increases. That we don't want this thing. So that means the line design depend upon the length of the transmission line. If the transmission line, so what is the length? That is the we have to keep in our mind, and which type of the structure we require to use it, and which type of the insulation we have to prefer, and which type of the switchgear and protective equipments we have to use it, and how many chances of faults may be occurred at that area, and at the same time what is the voltage to be dropped from this place to this place, regulation also you have to consider. And finally, so we have to choose it, weather condition also we have to keep in our mind. So what is the wind forces at that area, and based on the wind forces we have to select the structure size also, structure shape also. At the same time, the ice deposition also we have to keep in our mind. So this is a main basic thing of selection of design lines. So here, so we are going to select the transmission line based on these factors we have to keep in our mind. Now after so considering these all factors, now let us we are going to installing the transmission lines and distribution lines. Now what is the meaning of the transmission line? What is the meaning of the distribution lines? As we know that the power generated at remote areas. So for example, hydropower plant is placed at a very away from the thickly populated area. It is near the hill areas. At the same time, the thermal power station also somewhat away from the major cities. For example, if I are taking the Hyderabad is the heavy density, low density area, but NTPC's Ramagundam is nearly 200 kilometers away from Hyderabad. So where we are generating the large amount of the electrical energy in NTPC. So from NTPC to Hyderabad, we have to transmit the energy generated in power station. So we require some transmission lines. We require the distribution lines to meet the load demand of consumers in Hyderabad. Then what are the transmission? What is the distributions? Let us once again we have seen it may comes in power system also. Just at a glance you can see here. What is here? The power primary transmission. The transmissions are two types: transmission system and distribution system. That means transmission lines and distribution lines. Transmission lines generally is the generating site, where the distribution lines generally towards the consumer load centers. That means the transmissions are mainly the primary transmission and secondary transmission. In primary transmission, so the voltage range that may be 132 kV to 765 kV voltage range of transmission lines, we can say it the primary transmission lines. This is the mainly the from generating station to from power grid to nearby cities centering centers. So all major substations are surrounding the city only. So that means from generating plant to nearby city load center. So we are providing the different sizes of transmission lines. Those lines are known as the primary transmission. So its voltage is nearly 132 kV to 765 kV voltage. After that, so what will happen? Once again it is stepped down by using PTR in nearby surrounding the substations. That's the receiving stations. In receiving stations, it is 400 kV or 765 kV, it step down to 66 kV or 33 kV voltage. Now in Telangana, so we are only preferred for 33 kV, not 66 kV. That means 132 kV by 33 kV is stepped down by using number of PTRs surrounding the city. So this type of the stations we can say is the secondary transmission lines. That means 33 kV lines we can say the secondary transmission lines. So at the same time these lines may be called as a primary distribution. Some distribution means we have to distribute the energy, whatever the energy generated, that has to be given to the consumer on the based on the some tariff. So that means we have to distribute the energy generated to the consumer. So that means here the 66 kV to 11 kV, that is known as a primary distribution. So we distributed the consumer here. Now after that, that is we can say the substation here, primary substation. So from here also we are high voltage to 33 kV to 11 kV or 11 kV we are step down by using the power transformer and given to the some lines by using the PSC poles, rail poles and different types of structures. That is known as a primary distribution lines. Now primary distribution lines to secondary distribution. The secondary distribution is nothing but our DTR, nearby street, where it will take the 11 kV input and it will give the 400 volts or 230 volts as a single phase given to the domestic appliances. These lines are known as the secondary distribution systems. So these are the things you have to remember. Now, so what is the purpose of this transmission distribution first? What is the aim? That means the aim is mainly, so we have to supply the every consumer in India. So every person has a right to take the electricity. So that means we have to give the a quality of electrical supply to a consumer. That means, so we have to give the quality of the power supply means, so it is the voltage, we have to give the voltage, a reference voltage. So prescribed voltage to the consumer plus or minus 10% variation. That means, so if you are giving the 230 volts plus or minus 10 voltage, 23 plus 23 minus, we are going to give the voltage to the consumer. At the same time, the frequency also we have to consider plus or minus 5%. That means the Indian frequency is the 50 Hz. Now plus or minus the 5% means 2.5 Hz. So that means so 47.5 Hz to 52 Hz of the frequency may supply to the consumer. That plus or minus 50. That is the main aim to. At the same time, the power given to the consumer should be, it is a qualitative and should be reliability. So the continuity of the supply we have to maintain. It should be very reliable to the consumer. That is how we have to keep in mind. So here, so if you are seeing the what is the need of the distribution lines. So distribution lines are supplying to the commercial loads, agricultural loads, industrial loads and residential loads. So this is the main need of the distribution lines. Now let us see our subject. Now what do you mean by the what are the main components? For here we are going to prepare the estimation for the LT line, low tension line and HT line, 11 kV lines. Sometimes we can go 33 kV lines also. So that purpose, what are the main components required for transmission of distribution of power from substation to nearby load center? Let us see. So first you can see here. So this is what you can see. This is one support, that may be the support with different type of the support. PSC poles, rail poles, iron poles, different type of the GI round poles, and olden days we are using the wooden poles also. This is one support because we are using the overhead lines, not underground cables. Now first we should know this is the pole, PSC pole. So that is a cement pole. So in case of the LT poles, so low tension poles, it is 8 meters. For the 11 kV, 9.1 meters PSC pole generally used in our distribution system. After that, what is required? We require the cross arms. So the cross arms are consist of the cross arm. It's a straight cross arms or V-shaped cross arms also generally we are using. So straight generally use, or we can use the straight or vertically. Sometimes we can use the at the corner end we can use the vertical some places, so we are using the horizontally. Sometimes we can use the V shape or V shape type of the cross arms also, the MS type, the MS type of the material generally used, mild steel materials are generally used. Then after that, here with the R phase, Y phase and B phase, another is the neutral. Neutral, there is no need of the now insulation. Now the insulators are generally in distribution system, we are using the pin insulators. You can see here, these are the 3 pin insulators placed at a equidistance. And now next, what is the part? So you can see the another is the main important is the transmission of energy through conductors. So already you have seen the conductors are copper conductors, aluminum conductors. Now copper is costly, so we are prefer for aluminum conductors. So what are the difference with the aluminum conductors? Already you studied in first year level, that is the ACSN conductors, AAA conductors, AA conductors. So these are the conductors generally used in our distribution system. Now after that, suppose at the end, at the corner, and so we require some support to the our poles. Then we can use the one stay wire. Stay wire, you can see in the figure, there is a stay wire we are given to the at the opposite side of the end. So at the same time, to avoid the any leakage current to the ground or nearby persons or animals, we can use a guy insulator. You can see here one guy insulator also you can provided in stay. If not possible to place stay this side, then the pole has to support the other side, then we can use for a strut. You can see the strut is nothing but the same basis pole, the half of the pole is supported in the opposite direction to the stay wire. This we required. Now next, what is that one? We require the dangerous plate also we have to place on the pole. So these are the main basic items. So only not this one, so we can place different components also. So we required, so what are the components, main components, and the barber wiring we required, at some crossing, road crossing, and at railway track crossing we require the V boards, V guards also we required, and guarding requirements are required. RYB face plates are required, dangerous plates is required. You can see the dangerous plate, and barbed wires, butt guarding sometimes, so butt guarding also we required, and the fuses and isolating switches are also sometimes wherever we require the cut point. So at that condition we can use the one isolators also we required, and sometimes we require the lightning arrestor also required. So these are the different type of the components for a support. So let us assume this is a LT pole or HT pole, 11 kV pole, or LT pole 400 kV, 400 volts pole. Now you can see the in case of the transmission line, what is happening in case of the transmission. Let us see in transmission also same thing. So it has also cross arms, the structures, and at top you can observe is the earth wire, ground wire, and the conductors are, so you can see the conductors, the double conductors and the quadra conductors, different type of the conductors also based on the current capacity. Next, at the same time, dampers also used in transmission lines to avoid the wave of the whenever it becomes the moving of the conductors, dampers. And insulators, string insulators, so by using the disc insulator also we are used here, and tower structure, GI structure also we used, and spaces also provided on lines. These are the basic components in a high EHT transmission system. So here same thing here, so in poles also we require the cross arms, here also we require the cross arms. Poles also require the insulators, here also we require the insulators. Structures, spaces, everything is required in case of our system. Now, so after knowing that, let us see what are the main components. So already we have seen components. Let us see one by one its basic ideas. What is the use of these equipments? Now how they are used in our real world. Let us see one by one and quickly. Now you can see here, first of all is the support. So what is the mean support? The support is nothing but you can see the support. Already you have seen the steel towers, the EHT towers, UHV towers, and the rail poles, iron poles, PSC poles, that is nothing but cement poles. And olden days the olden days generally we already used the wooden poles also, but nowadays wood is very costly and rare, so we are avoiding the wooden poles. So these are the supports. What is the function of the support? The function of support, you can see the support. What is the function of support? The function of the line support is to support the conductor so as to keep it at a suitable level above the ground level. That means it has to maintain some ground clearance. Let us see how the structures are available in normal days later. Now next, another thing is the cross arms. Cross arm, so name itself is a cross arm. These are mainly used on the pole structures for supporting the conductors and insulators. So it keeps the live conductor in a position. So these are the different type of the cross arms. Angular sections and straight sections we can see. So you can see here the cross arms are straight and angular one. Next, another part is on which we are going to place the insulators. Now, so this is what is the insulator? So insulators are different types. So already we have seen disc insulators, pin insulators, strain insulators. In case of strain insulators, LT shackle insulator, and in case of the HT we can use the same disc insulators as a strain insulators. What is the purpose of insulator mean? That means these are used for supporting the conductors and also taking a strain or suspended conductors. Generally, these are the function of insulators. Now after that we are going to get another is the main conductor. What is the purpose of the conductor? So already you studied in conductors copper comparison between the copper conductors and aluminum conductors in first year level. So these conductors are generally carries the electrical energy from source to load centers. That is means the conductors, depending upon the rating of the current, span length, either copper or aluminum, ACSR and any other composition conductors are used in overhead lines. So already let us see one figure later. Now another one is the stays and guys. Here are the supporting axes. What is the purpose of this one? These are mainly used for supporting the poles at the ends at the angle points. It will give some strength during the wind pressure. So what are the different stays and guys we will see in later. Now another is the lightning arrestor. This is a very protective device. So what is the lightning arrestor? These are mainly used to discharge excessive voltages built up on the line to earth due to the lightning. Whenever the lightning discharges. So already we have seen that lightning are the two types, the class A, class B type. So direct and indirect lightning. So whether which type of the lightning, so whatever the high waves, traveling waves comes in the line, that has to diverted into ground without passing to a costly equipment. Let us see later. Now, so what is these are the lightning arresters. Already the different types, rod type lightning arresters and spear gap lightning arresters, and mainly is the thyroid type lightning arresters, valve type lightning arresters, expulsion type lightning arresters. These are the famous lightning arresters. So let us see later. Now another is the fuses and isolating switches. So name itself, fuses, the KitKat fuses, basic fuses, and isolators. Isolate is isolate the circuit under no load conditions. In case of the LT AB switch, it can be operated under load conditions, but in case substations the EHD substations, we always operate the isolator after tripping the circuit by circuit breaker. After that, we have to operate only. So, what is this purpose of this one? These are mainly used to isolate the different parts of the overhead system. These are the different of these things. Now, you can see the circuit card fuses, HRC fuses, and single break and double break switches are generally we can observe this type of the switches. Now, another one is the important one is the earth wire. So, what is the purpose of earth wire? So, as you name itself, for protection of lightning. The heavy current, whatever the current comes, that is diverted to the ground. This wire is run on the top of the towers to protect the line against lightning. This is the main thing to protect our structure. So, next another accessory is the miscellaneous. What are the miscellaneous? So, you can see the other small items, V-guards. So, what is the help of the V-guards? These are provided below overhead lines running across the public streets lines for safety of public. That means it is a guarding. Whenever suppose the line breaks, it may comes to contact the person who is walking on the road or vehicle who is going on the road. So, to avoid that one, we are using the GI wire one guarding. If it breaks, fallen on the guarding is solidly earthed. Automatically, it indicates the tripping of breaker at substation. Next is the phase plate. Phase plates, these are used to distinguish the various plates, that is the R phase, Y phase, B phase and neutral bands at earth. So, it indicates some accessories. Now, another is barbed wires. What is the barbed wires? Generally used, the barbed wire are generally, so these are placed on each pole. So, to prevent climbing of unauthorized person to the pole, whether disconnect or reconnect the circuit, because electricity is a very good slave, but it's a bad master. So, there is a electrical short. So, any other unauthorized person may climb the pole. To avoid that one, we are using this barbed wiring. Next is board guards. Board guards is another thing. This is a stick of ebonite with a rod top is fixed near the insulator on the cross arm to prevent flashover due to the birds pecking on the conductor. We can see on the figure also. So, these are the things. So, we are going to see. These are the basic things. What are the things? One is a support, another is a cross arms and the clamps, and clamps are used to keep the cross arms in position, and insulators to insulate the live conductor from supports, and conductors which can carry the energy from source to destination. Stays and guys are supporting the support, the mechanical support to the poles or a structure, and lightning arresters are divert any discharge of lightning during the lightning period, and fuses and isolating switches is the controlling devices, and earth wires are also the protective devices, and miscellaneous are the supporting to the maintenance of our distribution lines. These are the main components in distribution system. So, we have to keep this all items in a problem. So, these are the things we have to know. So, let us see. So, one by one in figure in the real world, how it is the real world. So, already you know this thing. Now, support, you can see the figure. The support, here is a support, is a supporting the live conductors. So, these are the live conductors. So, the function of the live line support is to support the conductors so as to keep it at a suitable level above the ground level to avoid any touching to the ground persons or ground vehicle or ground things. So, we have to ground clearance also we have to keep in our mind. So, as you know, as per Indian electricity rules, we have to keep some ground clearance across the road, along the road, and for the ground clearance also changes based on the voltage range changes. That is the things we have to remember. Here you can see the different type of the rail poles. It's a double structure, and here is the one single. The height, the distance also we can see the some lines are HT lines, and below this one LT lines also going using this purpose. And you can see the these are supports are different types. Here also different shapes and different size and supporting purpose. And you can see that easily this is a V shape cross arms, and these are the different structures. And this is a tower for the EHT, the ultra high voltage station, and this is also different type of the structures, whether it's the 220 kV or 400 kV and 765 kV. Based on the voltage, we have to maintain the ground clearance very height. So that's why, so these are the structures, different of the structures for the different purpose of transmission of power energy from one place to other place. Now coming to the another equipment is the cross arms and clamps. Now you can see the here is a 133 kV line. Here the cross arm V shape cross arms and connected and with the pin type insulators, and the cross arms are fixed with a clamp, you can see here. So this is one example of the cross arms. Now you can see the another example. Here is a H type structure where a cut point we required here, some jumpers are provided. So this is the first one case is a normal running condition where this is at the cut points, every fifth pole there is possible to cut points. So this is also cross arm, straight cross arms, and you can see that here is another cross arm. Generally you can observe this type of the cross arm in railway traction, and this is a V shape, different of the cross arms generally uses in this one. Not only this one, so different applications you can see the these are the different type of the cross arms and clamped different shapes. So based on our requirement, so the double cross arms also so required here. This is the some of the cross arms you have to remember. Now coming to the another important is insulators. What do you mean by the insulators? So insulators is nothing but these are used for supporting the conductors and taking a strain and suspending the conductors in a required position. So you can see here the olden days we are using the glass insulators are three types mainly, is a porcelain insulators, glass insulators. The latest is the rubber insulators, nothing but is the we can see the PVC insulators. Here you can see the these are, and further is classified also pin type insulators, disc type insulators and strain type insulators. In strain type insulators, the LT side we can use the shackle type insulators. You can see the a last figure, this is a shackle insulators. LT side we can use the shackle insulators, and this is a glass pin type insulators, and this is the bush type insulators. So you can see these are different type of the insulators generally using here. And types of insulators you can see here also you can see the bush type insulators where we can use the transformers. And this is on the guy insulator. You can see second one is the top, second one is the guy insulator. It can be used for the in stay wires. And last of the this is also shackle insulators and bush insulators and pin insulators. And here is another type of the insulators. So these are the different applications to support the conductor in a position from support. And coming to the another part important is the conductors. So as we know that conductors already you have seen in first year levels. The conductors are solid conductors, hollow conductors, stranded conductors, WAC conductors, AAC conductors, ACSR conductors, ACSS conductors, ACCR conductors and ACCC conductors. Here S means steel, this is a mechanical support, reinforced. So these are the different type of the conductors generally used in our distribution system as well as in power system to transmit the energy from substation to load center. So generally these are the different type of the conductors used. Now already you know this is all aluminum conductors, all aluminum steel reinforced conductors. So different the conductors already you know these characteristics. Now another is you can see the cross section of this one. ACSR conductors, you can see the in middle there is a steel, it is a mechanical support. At the same time, so what is the need of the stranded? So instead of solid conductors, why we are going to use the stranded? So that means you can see the solid figure is the here you can see the first figure, the solid first figure and stranded last figure, same capacity. So what is the difference? Because AC is nothing but is always flows current only surface of the conductors. That means so we are not utilizing the center conductor. So hence so wastage of that conductor. So to avoid that one, we are used the standard conductor. At the same time, instead of solid conductor, the standard conductor is a very flexible and at the corners. So that's why we prefer for the stranded conductors instead of solid conductors. Solid conductors sometimes we the special cases we can use that thing. Now you can see the cross section areas of different conductors, ACSR conductors, ACSS conductors, different the industrial application purpose they are used it. Now you can see the how these conductors connected to distribution system or 11 kV or distribution system. How here you can see these are two lines, that is this side and that side you are connected the insulators, the jumpers are provided here. There is a cut point. And here you can see the HT by LT lines. The top one is the 11 kV and bottom one is the LT voltage. So they are used the ACSR conductor for transmission. And in transmission also you can see here these conductors. So R phase, Y phase, three phase conductors for carrying the current. At the same time safety purpose we can the earth wire also we placed at the top of the conductors. So open the ground wire overhead ground line, so that is the protection purpose during the lightning. These are the conductors. Now coming to the stay and guys. So what is the purpose of stay? Stays, these are the mainly used for supporting the poles at the ends at the corners. So that is the main thing of the stay. The stay is so you can already you drawn in figure in drawing level in second year level. So this is a one stay you can see here, and this is another type of the arrangement the stay. You can place the one pole. The pole is supported at parallel. Here is the first one is the angle. It is the some parallel. Now so here you can use another type of the stay also. So these are the different type of the stays for different applications. Stay means only support. If not possible to use the stay wire, then we can use the strut. The strut is nothing but it is a solid nothing but is the same type of the pole, half of the pole. The strut is mainly, so strut is used opposite direction to the stay wires. You can remember that thing only. Now you can here also you can stays and guys for the H type of the cut point. You can see here the cut point. So H type of the cut points. Here you can observe the four stays, two sides, and at the same time each stay contains the guy insulator. You can see the guy insulator. Here also you can see the guy insulator. The guy insulator is the only is a mechanical support, as well as if any leakage currents to the cross arms, that is avoided to the ground here. Suppose what will happen? So stay is from top to it is connected to the ground. If any animals or any person's contact, there is a leakage current, there may be electrical shock. To avoid that one, so we are using the one insulator in between the stay. And you can see the strut, real strut, how he is doing the work in the strut pole. So this is one thing you can see here. Now coming to the types of light, next is the lightning arresters. Types of lightning arresters. What is the meaning of the arresters? The arrestor is nothing but it's the main important is these are mainly used to discharge the excessive voltages built upon the line to the ground due to the lightning. During the lightning, the whatever the voltage charges induced on the top of the transmission lines, that are wave lines. So that waves will enter into the equipment, which is a costly equipment, transformers. So what will happen? So these waves are traveling waves. These are high voltage waves having the some lakhs of voltages. But our transformers are designed for the some rated voltage, 130 kV, 220 kV or 765 kV. But one lightning may contains some lakhs of voltages, very higher than the rated voltage. So once that much of the voltage enters into our costly equipment, then insulation, first of all, insulation fails. If the insulation fails, automatically, so phase to phase or dead short may occur, total the equipment may spoil. To avoid that one, so we are using the before costly equipment, either side we are going to use a lightning arrestor. So this lightning arrestors are different types. Already we have seen rod type lightning arrestor, simple and best, and a sphere gap, you can see the middle figure, and thyroid type, valve type, expulsion type, different of the lightning arrestors for the different voltages purpose. Also you can see the different here. Now you can see the another 400 kV line. So how they are using, you can see here is a top one is the insulator and parallel to the another lightning arrestors. So this is the protection purpose, high voltage 400 kV lines. And you can see the in substation, if you are seeing the entering any substation, is generally, so before line enter into the substation, first the first equipment is a lightning arrestor. So lightning arrestor, you can see it. If any waves, when a high voltage comes in transmission, so before entering to the substation, it will take care of it. So this is the purpose of lightning arrestors. Now lightning arrestors are different types. You can see the small size to a big size, based on its voltages. That is the thyroid type of the material, the clay type of the material. So especially design materials are generally, it has a, what is the, already I think you know these characteristics. The lightning arrestors having the negative characteristics, negative resistive characteristics. That means under normal voltage and frequency condition, it acts as a good insulator. When the high frequency, high voltage comes, it acts as a very good conductor. That means if lightning comes, it acts as a good conductors. When normal power comes, it acts as a good insulators. That is the negative resistive coefficient of properties of lightning arrestors. So lightning arrestors may be sometimes so unable to bear that one, it blasts sometimes. So these are the one disadvantage of the lightning arrestors. Now coming to the fuses and isolating switches. Now if you are observed anytime in DTR, whenever the lineman is trying to open the gang operating system AB switch, you might observe this type of the spark. That means the AB switch, air brake switch, can be operated under the normal current, low voltage system we can operate it. Whenever the closing and opening the AB switches, there is a possible to spark occurred. So that's why the AB switches are designed such a way that its making and breaking capacity should be in a limited values. So but in case of the isolators, so isolator is nothing but it can be operated under no load condition only. So that's why it has no making and breaking capacity. You can see here, so fuses and switches. So here AB switches are generally used. These isolators are generally used in substation. You can see the substation is a single break isolators, double break isolators generally used in our substations. So what is the purpose of this one? The fuse is also the protective devices. Isolator also is a controlling device. That's nothing but switch. Now we can see the fuse. Fuse also is a rewirable fuses, you can see here. So what is the purpose of fuse? If any abnormal current comes, automatically the first of all, before giving the heavy current to the load equipment, it will first of all blow out. Then there is no heavy current goes to the motor to avoid the burning of the motor equipments. Now so these are the some parts of a overhead lines. Coming to the miscellaneous items. So you can see here barbed wires. So what is the barbed wires? These are placed on the each pole to avoid climbing up any unauthorized person. So mainly at the same time this also used in the surrounding our substation. So entered unauthorized person into our substation, because our substation is always there is a possibility induction to avoid entering up unauthorized person or animals or something. So we are using some barbed wire surrounding this one. So that is the one thing you have to remember. Next you can see the guarding also. Already we have seen the guarding also. You can, this is the avoid the guarding. So that is these are the provide the below overhead lines. So you can see the guarding for telephone lines. So the one is the telephone line, another is the power line. So here in between we are using the one guarding system. Another figure you can see the rail track, and over this one we are using the HT lines. In between we are using the one guarding system. These are the different of the guard systems. Now you can see the different of the here also. This is the another type of the guarding systems. Cradle tap. Now so another equipment is a dangerous plate. So it indicates what is a dangerous plate. So name itself it indicates the these are the provided on each pole as a warning measure to persons who is try to touch the live parts. Next this is a bird guards. A stick of ebonite with a round top is fixed near the insulator. You can see in between. So now the bird is unable to sit at this place. So otherwise what will happen? It will sit and touches its beak to the live wire. There is a possible to electrical shock. So at the same time our breaker also trips, unnecessary tripping of breakers due to this short circuit of faults. To avoid that one we are using the bird guards also sometimes here. And another one is the earth wire. This is a very important earth wire. So earth wire is a run on the top of the towers to protect the line against the lightning. So because in substation we are using the lightning arresters, but along the transmission line some hundreds of kilometers, how we are going to protect this one? So by using this one we are using the earth wires. The earth wire shields the total transmission line along the line, and it is solidly grounded to the each tower to the earth in the ground. This is one example of this one. And so these are some supporting to our things. Now I think these are the very simple and easy. Before going to do the problems in overhead transmission lines, what are the main components required, what are its characteristics, how they are connected in the real world, you should know. That's why I prepared here only theoretical part only. So next class we are going to do the one small LT problem and HT problem, how we are going to estimate the materials required for one transmission line for a given distance. So I think you know you have some idea on our distribution and transmission lines today. Now what we have studied today in this session, we have learnt about first point is the factors affecting on selection of powers. So this is one thing. So second point, what is the classification of power lines? How the power lines are classified based on its voltages. There are transmission systems and distribution system. Transmission, primary transmission and secondary transmission. Distribution, primary distribution and secondary distribution. So during this one, what are the different components required? What are the purpose of each component? We have seen. Next, and main components of overhead lines. So in a LT4 distribution system, whether it is a 400 volts LT line PSC pole or 11 kV line. So what are the basic components required, and each component, what is the purpose, what are the different types? So already we have seen. So these are the some things we learned. I think so you have the some idea on this one. Next we have seen the application of various components. Now thank you very much for listening this thing.